This video is our third assignment in geometry during the e-learning spring 2020 pause in school. What we're doing here is pages 21 and 22 in the notepad. In the previous assignment, we were talking about parts of a circle, and we had specifically talked about this shape, a slice of a circle, and this slice had a name called a sector. Now what we're going to do is we're going to continue talking about what fraction of a circle it is, and eventually we'll calculate the area of just this part of the circle and the circumference of just this part of the circle. To do that, we need to talk about the fraction of the circle that's represented. In other words, this slice or sector is 45 degrees of a circle, and what we want to do is know what fraction of the circle that is. The whole circle is 360 degrees, so this slice is simply 45 out of 360. So I can take that 45, make it over 360, and then simply reduce this fraction to find out what fraction of the circle it is. 45 over 360 reduces to 1/8. So this slice is 1/8 of the circle. For each of these other problems, you're going to do the same thing. This one, number 12, the slice is 90 degrees, so we want to know what 90 out of 360 is. Now you'll have to reduce the fraction. If you have your black calculator with you, you can reduce it that way. You can reduce by simply breaking down the numbers and dividing both of them by seeing what you can divide them both by. If you need help reducing, you can simply find fraction reducers on Google. Just as an example, I can type in fraction reducer, and there's a whole bunch of different types of calculators that will come up on Google, and you can simply type in something like 90 over 360 and ask it to reduce it for you, so you can find this. Oh, that's 1/4 of the circle. So your answer number 12 would be 1/4. You can do the same thing with problems 13, 14. Again, finding what fraction of the circle each slice or sector represents. The problems here on the bottom of page 21 are the opposite. I'm telling you, here's the fraction of the circle I want, and I'm going to ask you how many degrees is that. Well, that's very, very easy. This first problem, it's half of a circle. So what we want to know is how many degrees would that be? Well, the full circle is 360, so basically just what's half of 360? So in this case, we just do 1/2 times 360. I apologize about my handwriting. I'm writing with the mouse pad. And then this will turn out to be 180 degrees. You do the same things with problems 16, 17, and 18. Just multiply the fraction by the full circle. You should be able to finish page 21. On page 22, we're going to actually now do the calculations we've been building towards, which is here's a full circle, and we're going to calculate the area of just this slice of the circle, this sector. It's real simple. We're going to find the area of the whole circle. That's going to be your first step. Find the area of the whole circle. No problem. This is a circle with a radius of 12, so we're just going to plug 12 into our area formula. Pi times 12 squared, you'll get 450 something for your area. And then 50 degrees is the part that we want. That's out of 360. So we're going to take that answer. We're going to find out what fraction that is. So you're going to take 50 over 360 and reduce that fraction. And then we're going to take the answer number 1, the area of the whole circle, times our answer number 2, the fraction of the circle we want. And that is our step 3 to find the area of just that slice or sector, what we call sector area. If you do it properly, your answer should just be a little bit more than 60. Now to shorten that up, we have a formula for this, and the formula is kind of a big, ugly, scary looking formula, but it's not that bad. The area of the sector, right here, which is the area of just our slice in these 3 problems, is pi r squared, that's the area of the circle, times our angle over 360, times the fraction of the circle that we want. So we just take the area of the whole circle times our angle over 360. So for our first problem here, we're going to find the area of a circle with a radius of 16. So we'll do pi times 16 squared. And again, all we've done here is we plugged in 16 for the radius right there. Pi times 16 squared, that's the area of the whole circle. But we don't want the whole circle. We only want 45 degrees out of that 360. So times 45 over 360 degrees. And this will tell us the area for just this gray slice of the circle. So using this formula can be a shortcut for this. It's pi r squared, the area of the circle, times our angle. Remember, this little symbol theta represents an angle, times our angle over 360. So for any of these problems, all we got to do is type in the radius of the circle for r and the angle we care about for theta. And we just plug those in for these two formulas. For this last one, it looks a little bit weird, but you're doing a huge 285-degree slice. If you do that right, you should get just a tiny bit over 100 for problem number 1. And then you can do problems 2 and 3 the exact same way. This is finding the area of a sector, or sector area. Finally, down here on the bottom of page 22, we're trying to find the length of this arc. That's part of the circumference of the circle. So we're going to do this almost the same way we do arc length. We find the circumference of the whole circle, which is 2 pi r, which is part of the formula here, and then multiply by the fraction of the circle we want. In this case, it'll be 210 degrees out of 360, which is the second part of that formula, times our angle over 360. So to find the length of that arc, we can just plug the radius into this formula. So 2 times pi times the radius is now 2 times pi times 12, times our angle out of 360. So times 210 over 360. And the rest is just a calculator problem. For problem number 4, you should get just a little bit short of 44 inches for our answer. And for problems 5 and 6, plug 8 in for the radius in number 5 and 160 for the angle. And number 6, plug 5 in for the radius and 50 in for the angle. And that's it. And it's mostly a calculator problem. The hardest part about these problems is not being freaked out by how ugly looking this formula is. Hopefully the formula makes a little bit of sense to you, and it can make it a lot easier to perform these calculations. All right, and that's the end of assignment number 3, finishing pages 21 and 22.